Hello, my name is Trevor Lee, and I will be explaining the RoboDog. Why choose the RoboDog? This project addresses the need for an affordable and modular robotic dog that allows small-scale developers, students, and engineers to customize to their various applications and needs. We approach this to add as much complexity to a cheap robotic dog kit that can compete with complexity to, let's say, something like the Boston Dynamics dog without a $75,000 price tag. What have we added exactly? So as you can see, we've added a LiDAR system for obstacle avoidance, a microphone and speaker, where we'll get into this later, but it will allow for like a voice control mode where you can talk to the dog, it'll talk back to you, and you can also give it commands. We've installed UWB chips and also a UWB anchor, two UWB anchors and a UWB tag that the user wears to allow trilateration to the user and allows the dog to follow the user. We also installed 3D printed supports that allow the UWB tags to be spread out far enough to where we can get pretty accurate measurements. We've also installed a camera that allows for gesture control, and these gestures will make the dog do a predefined action, and an Android app to allow for a little bit of customization and to toggle modes from gesture to voice mode. For our proposed solution, we wanted to install 3 modes: voice command mode, gesture mode, and user tracking mode, and then have a mobile app that can toggle each of these modes. Also, as you saw on the last slide, we did do 3D printed supports and then match the robot dog color to that. These are our 3 core modes. As you can see, on the left it's user following mode. This is a live representation of how the dog actually follows the user and how it can get its location using the tag. So this is about a pretty sped up 20-second video or 20-second GIF of me just walking around my room, and you can kind of see where, like, how it tracks me just kind of walking around. In the middle, you can see voice control mode. This is one of the nice personality. You can also have customized personalities to the app, but for this one, you can see how when you ask it, "How are you today?" it responds through the speaker with, "Hello, I'm here and ready to assist you. How can I help you?" with no action. But when I tell it to go left, it says, "Of course, I'll happily go to the left for you," and you can see the action is left. This is all done via a large language model, specifically 3.5 turbo, so it allows for very, very quick response times, also with a little bit of inference. That allows a pretty good contextual base. And also in the app, you can input context. So say if you wanted to use it as a tour guide, you can input context of the of the places you want to see. And on the right, gesture control mode, you can see when I change my hand, it changes the gesture up top. Those are also fed into actions. Future work, we would like to have done live streaming from the camera to the app and then have real-time control. We also wanted to do real-time facial recognition to actually remember people and remember the conversation they had with those people. Maybe QR code scanning to allow for a little bit more functionality on that, and object detection. This would just add more complexity and allow it to be more customizable for the average engineer. Overall, we added UWB tracking, LiDAR-based obstacle avoidance, responsive gesture recognition, voice control, and an Android app to switch all these modes, and then also it's all complemented by a 3D printed system of the UWB anchor wings and a wearable tag, all in the Charger blue color. And overall, this project provides an affordable, modular, and customizable robot companion and allows for engineers to apply them to their needs. And doing this all at a very cost-effective manner. So thank you.